All right, let's talk about something that trips up a ton of Android developers. Android's architecture components, things like ViewModel and LiveData, they're incredibly powerful. But they have these hidden traps, these little gotchas that can quietly sabotage your app's performance. So today, we're going to hunt down 5 of these silent killers, and I'll show you exactly how to fix them.
So I want you to ask yourself right now, are these mistakes hiding in your code base? Because by the end of this, you're not just going to be able to spot them, you're going to understand the why behind the fixes. And that's what makes you a much stronger developer. First, let's do a quick refresher on our 2 main characters.
First up, we have the view model. I want you to think of this as your data's ultimate survivor. You know when the user rotates their phone? Android might completely destroy and recreate your UI, but the view model, it just hangs on, holding on to that data like nothing happened. This is what stops those annoying reloads and keeps the user experience buttery smooth. And then we have LiveData, which I like to call the smart messenger. Sure, it delivers data, but its real superpower is that it's lifecycle aware. It's smart enough to know if your app is actually on screen and ready for an update. If it's not, it just waits. This little trick is what prevents a whole class of crashes and keeps your app from doing a bunch of wasted work in the background. Okay, foundation set. Let's get into our first and maybe the sneakiest mistake, leaking your LiveData observers, especially inside fragments. This one is so tricky because your app isn't going to crash, it's just going to get weird, slower, buggier, and you'll have no idea why. So take a look at this. The code on the left is the trap, and the code on the right is the way out. The change is tiny, right? We're just swapping this for get view lifecycle owner. But the difference in what's happening under the hood is massive. See, get view lifecycle owner is all about getting a lifecycle that is tied specifically to the fragment's view. The buttons, the text, the stuff the user actually sees. It's a clean, safe connection that knows when to let go. Let me show you why that's so important. So here's the absolute key. A fragment and its view have 2 different life cycles. When you navigate away from a screen and come back, the fragment object might still be alive, but its view gets torn down and rebuilt from scratch. If your observer is attached to the fragment itself, it never gets the memo that the old view is gone, so you just keep piling on new observers, and when an event happens, they all fire at once. By using get view lifecycle owner, you tie the observer to the view. When the view is destroyed, the observer is destroyed with it. Clean, simple, no more leaks. Okay, next up is a mistake that hits you right where it hurts, your user's data plan and your own server costs. I call it the reloading trap. This is when your app just keeps fetching the same data over and over and over again for no good reason.
On the left, you see the classic pattern. We're kicking off a network call from inside the fragments on create view. The problem? On create view gets called every single time the view is created, and that includes every time the user rotates their screen. The fix is so simple. You just move that initial data load into the ViewModel's constructor. Since the ViewModel survives that rotation, its constructor only gets called once, when it's first created. That's it. Problem solved.
And the fallout from this little mistake is not pretty. You're literally burning through your user's mobile data, you're hammering your own servers with pointless requests, and you're creating this janky, clunky user experience where the screen flashes and reloads. Honestly, it completely defeats the whole purpose of using a ViewModel in the first place.
Let's move on to mistake number 3, which I like to call the clingy view model. This is a classic memory leak where your view model just refuses to go away when it's supposed to because something with a much longer lifespan is holding it hostage.
So check out this scenario. On the left, you've got a singleton, maybe a repository object. Singletons live for pretty much the entire time your app is running, and in this case, it's holding a direct reference to a listener inside our view model. So even when the user navigates away, and that view model should be destroyed and garbage collected, it can't be. The singleton is still clinging to it. The fix, on the right, is your escape hatch. Inside the view model's onCleared method, you explicitly tell the singleton to let go. You set that listener to null.
And the result, if you don't do this, is a memory leak. Plain and simple. That view model and all the data inside it is just going to sit there in memory, taking up space until the user completely kills the app. It's a silent killer that will absolutely degrade your app's performance over time. OnCleared is your best friend here. Use it.
Okay, our last 2 mistakes are a little different. They fall under the category of good software design, of encapsulation. These probably won't crash your app tomorrow, but they violate some core principles and lead to code that is messy, unpredictable, and a nightmare to maintain down the road. So here are 2 habits you need to build to make your view models absolutely bulletproof. First, hide your mutables. The number one rule of ViewModel Club is you do not let the UI change the data directly. That is the ViewModel's job and its job alone. So you keep the mutable data life private and you expose a public, read-only live data for the UI to observe. This creates a clean, predictable, one-way data flow. Second, defer your dependencies. Your ViewModel factory might get created more than once, so you never want to create heavy objects like a database connection in its constructor. Instead, use lazy initialization. This makes sure those expensive objects are only created once, the very first time that ViewModel is actually needed.
Okay, we've fixed the big mistakes, we've dodged the bullets, now let's level up. Let's go from good to great with a few pro tips for really mastering live data. First things first, this is a big one. Set value versus post value. The rule is simple, but it is absolutely critical. Set value must be called from the main UI thread. It updates the value right then and there. Post value, on the other hand, is your go-to for background threads. It safely posts the update over to the main thread. If you mix these up, I promise you, your app will crash. So what happens when your UI depends on more than one stream of data? What if you need to combine things? Well, that is exactly why Mediator Live Data exists. This quote from the official docs nails it. It's a special live data that can listen to other live data sources. Imagine a user profile screen. You need the user's personal info, which is one live data, and you need their list of friends, which is a second live data. With Mediator Live Data, you can merge them. You can create a single source of truth for your UI that updates whenever the user's info or their friends list changes. It's an incredibly powerful tool for handling complex screens. Finally, let's address the elephant in the room. It's the 2020s, we've got Kotlin core routines, we've got Stateflow, we've got Jetpack Compose. With all these shiny new tools, is live data even relevant anymore? Is it obsolete? The answer is no, absolutely not. But you have to see it as part of a bigger evolution. Live data was created to solve a fundamental problem, managing UI lifecycles. And that problem has not gone away. In fact, it's more important than ever. Newer tools like Stateflow just solve that same problem in a slightly different way. So the real skill here isn't just learning one API, it's understanding the why we need to avoid leaks, why we need to manage state, why we respect the lifecycle. If you master those principles today with these components, you're not just fixing your current app, you're making yourself a better, more adaptable, and future-proof developer ready for whatever comes next.